Today we're going to develop a formula for the area of a surface of a revolution. We want to think about surface areas and how we can calculate surface areas of solids. So we'll start with a simple surface area. If we take a cylinder and we cut it along its edge, we can unfold it to end up with a rectangle. And we know that the area of a rectangle is the base times the height. So the area, or the surface area of our cylinder, just looking at the edges, not the top or the bottom, is just 2 pi RH. If we think about the area of a cone, that is just the surface area of the top part of the cone, not the base, we can do something similar. We can cut it along the diagonal, which we're going to call L, and unwrap it. If you can imagine taking a water cup from the water cooler and cutting it along the edge and unwrapping it, you would end up with a sector of a circle. And from trigonometry, we know that sector of a circle is 1/2 the radius. In this case, the radius is called L squared times the angle theta. And substituting back in for theta, we have 1/2 L squared times 2R pi divided by L, which simplifies to just pi RL. And if we just want to look at a section of the cone, we can take the formula we just worked on to get the area by taking the big wedge and subtracting the small wedge, as we see here. So the big wedge is pi R2 times that long length of the diagonal, L1 plus L2, or just L, minus the area of the small wedge, which is pi R1 L1. Using some similar triangles, we can find a relationship between the R's and the L's. We're going to distribute right here and then rearrange so that we can factor out an L1 from here. Then, using similar triangles, we can substitute back in right there and factor out an L2. And from here, if we take a new R to be the average of the larger and the smaller radii, then our area formula becomes 2 pi R times L.